Ever pondered why everything in the cosmos, from the tiniest particles to the largest galaxies, is in ceaseless motion? Why isn't anything at rest? Welcome to the enigma of constant motion, a universal phenomenon that has been the subject of curiosity and study for millennia. Our universe is a vast, ever-expanding stage where celestial bodies, including our home planet and its neighbors, are in perpetual motion. But why is that? Why isn't there a moment of stillness? Let's start from the beginning. The universe, as we know it, began with the Big Bang, an explosion of space, time, matter, and energy. From this cataclysmic event, the universe has been expanding, and everything within it has been moving. The motion of celestial bodies, including Earth and the rest of the solar system, is a part of this cosmic ballet. But why do these celestial bodies move? Why don't they just stop? The answer lies in one of the basic principles of physics. A body in motion tends to stay in motion unless acted upon by an external force. This law, known as Newton's first law of motion or the law of inertia, explains why the planets keep revolving around the sun, why the galaxies keep moving away from each other, and why you keep moving forward when you're in a moving car and it suddenly stops. Yet the motion of celestial bodies isn't just a simple straight line. The planets move in orbits, the galaxies in complex paths. This is where the force of gravity comes into play. Gravity is the invisible hand that shapes the motion of celestial bodies, causing them to move in curved paths rather than straight lines. So, yes, everything from the smallest atom to the largest galaxy is in constant motion, driven by the fundamental forces of the universe. It's an intricate dance of energy, matter, and space-time that started billions of years ago and continues to this day. To understand this better, we need to dive deep into the principles of physics and the history of our universe. The tale of cosmic motion begins with an event you've likely heard of, the Big Bang. Picture this scenario: a singularity, an incredibly dense point of matter and energy, suddenly explodes. This isn't your typical explosion. It's an expansion, a rapid stretching of space-time itself. That happened around 13.8 billion years ago. This event set the stage for the universe as we know it, and it also set everything into motion. In the wake of the Big Bang, matter and energy were flung outward, creating a cosmic momentum. This momentum is the reason why everything in the universe, from the tiniest particles to the grandest galaxies, is in constant motion. The celestial bodies we see in the night sky, including our own planet, are all moving, and it's all because of that initial push from the Big Bang. Now, you might be wondering, why hasn't everything come to a stop yet? Why hasn't all that motion from the Big Bang eventually slowed down and ceased? Well, this is where the concept of inertia comes in. Inertia is the resistance of any physical object to any change in its velocity. This includes changes to both the speed and direction of motion. An object in motion tends to stay in motion unless acted upon by an external force. So, in the vast emptiness of space, where friction is virtually non-existent, celestial bodies continue to move in accordance with their initial momentum, courtesy of the Big Bang. They have kept moving and will keep moving until something makes them stop. Inertia is the cosmic law that keeps the universe in motion. That's the origin of motion, but what keeps it going? Let's delve into the forces that sustain these movements. Gravity, the invisible glue holding the universe together and a key player in the perpetual motion of celestial bodies. It's a force that we're all familiar with, but its role extends far beyond keeping our feet firmly planted on the ground. Let's imagine the universe as a cosmic dance floor, with planets, stars, and galaxies twirling in a grand ballet. The choreographer? Gravity. It's the force that pulls everything in the universe towards everything else. It's what keeps our Earth spinning around the sun spinning around the center of our galaxy, and our galaxy spinning around the center of the universe. But it's not just gravity at work here. There's also the initial momentum, a cosmic push that originated from the Big Bang. When the universe exploded into existence around 14 billion years ago, everything was sent flying outwards. This initial explosion gave everything a push, a kind of cosmic kickstart that set everything in motion. So our celestial bodies are caught in a delicate balance between these two forces. On one side, we have gravity, constantly pulling everything inwards. On the other, We have the initial momentum, constantly pushing everything outwards. It's like a tug of war on a cosmic scale. Now let's consider our Earth. It is constantly being pulled towards the sun by gravity, but it doesn't fall into the sun because it's also moving sideways, thanks to the initial momentum. This sideways motion is just fast enough to balance out the inward pull of gravity, keeping Earth in a stable orbit. The same principle applies to all celestial bodies. They're all caught in this delicate dance between the inward pull of gravity and the outward push of initial momentum, a dance that keeps them in constant motion. Gravity and inertia work in harmony, but how does this motion contribute to the energy of the solar system? Let's find out. The ceaseless dance of celestial bodies is not just mesmerizing, it's also a source of immense energy. This energy takes two primary forms: kinetic and potential energy. Celestial bodies like the Earth and other planets are constantly in motion, orbiting the sun at phenomenal speeds. This motion brings about kinetic energy, the energy of motion. Consider our very own planet Earth, spinning on its axis and orbiting the sun, a journey of about 580 million miles every year. This movement generates a colossal amount of kinetic energy. But it's not just Earth. Every planet, asteroid, and comet in our solar system is in constant motion, each contributing its share of kinetic energy to the solar system's overall energy budget. Now let's talk about potential energy. This is the energy an object has because of its position relative to other objects. In the context of our solar system, the gravitational pull between the sun and its orbiting bodies creates a form of potential energy. For instance, if the Earth were to suddenly stop in its orbit, the sun's gravitational pull would draw it in, converting that potential energy into kinetic energy as it accelerates towards the sun. So, the motion of celestial bodies, governed by the laws of physics, creates a delicate balance of kinetic and potential energy. This energy balance is crucial for maintaining the orbits of planets and the structure of our solar system. It's this energy that keeps our Earth in a stable orbit around the sun, allowing life to flourish. In essence, our solar system is a colossal dynamo, generating and transforming energy on a scale beyond human comprehension. The laws of physics choreograph this cosmic ballet, with celestial bodies as the dancers, each contributing to the symphony of energy and motion. The universe is a grand ballet of celestial bodies, each following the rhythm set by the laws of physics, creating a symphony of energy and motion. Fascinating, isn't it?